Hi, team. Welcome back for some more learning. Thank you for showing up as well. Thank you very much for showing up for your learning. We are reviewing a 1.6 in our textbook on page 71. Can't see the 71 down there. Trust me, 71. Okay. 1.6. Determine the quadratic equation given its roots. All right, so we have questions like we know where this quadratic touches the x-axis. We know one more point. That's actually enough information to find the equation of that quadratic. And we're going to use the factored form to do these types of questions. Then we have one that has an ugly root, and then we have an application question is about a golf ball. All right, so let's take a look at these questions. So the first question, we have it copied out over here. We know that this quadratic has x-intercepts -2, 5, and it contains the point 3, 5. So make a sketch. Okay, and the sketch is not going to give you the answer, but it is going to give you useful information. So we know that there's a root there at -2. We know there's a root out here at 5. And then the point 3, 5 is also a point on this parabola. So I'm expecting an a value that opens downwards. All right. I'm expecting a negative a value. I bet it's -1. It's just a guess. Let's see. It's -1. No, it's going to be less than that. I bet it's like a half or something. Anyway, let's just do the math. You don't want to sit here and watch me guess. Okay, so I'm going to code those as points. So that's the point -2, 0, and that's the point 5, 0, and this is the point 3, 5. So I know that those are the 3 points. Now, first thing that I'm going to do is I'm going to take these roots and I'm going to put them into the form f of x. Some function of x is this quadratic, and it's equal to some value a, some stretch factor. I can predict it's going to be negative because this opens downwards. Some value a multiplied by x minus the first root, so -5, and x minus the next root, so that's +2. Okay. Now, all I need to do is input this here and here to evaluate. This is an x value, that's a y value. All right. So here's my output. That's like the output of this is like the f of x axis or the y axis. Okay. So I'm going to put in that 5 for f of x. So 5 is equal to a multiplied by x is 3. 3 minus 5 multiplied by 3 plus 2. Okay. And then here, 5 is equal to, this would be -2, and this would be 5. So this would be 5 is equal to -10 times a. I get that by evaluating that -2. Evaluate that, +5. -2 times +5 is -10. All right. Now, I have some inverse operations to do. Hold on to your hats here, people. My guess was exactly right. 5 divided by -10, that's -1/2. That's equal to a. What did we just find? We just found the stretch factor of this parabola. We had all the other ingredients of the equation right there. We were only missing that ingredient. So now it's time to sub that in, and then we're done. Okay, so it looks like this. F of x is equal to -1/2 multiplied by x minus 5 multiplied by x plus 2. All right, cool. Now test the points, see if they work. -2, 0. Well, if I put -2 in there, that would be a 0. So that would create 0 over here. So that point fits this function. This one, 5, 0. Oh, if I had 5 there, that would create a 0. So this would be 0. So that point is on this function. Now I'll test this one. 3. -1/2 times 3 minus 5. So 3 minus 5 was -2 times 3 plus 2, that's 5. So -2 times +5 is -10. We're going to multiply -10 by -1/2. That gives us 5. And indeed, that was the output we wanted. So all 3 points are on this quadratic. Good. We could also check in Desmos, but we don't need to because we're very confident that works at this point. Now, x-intercepts, -2 plus or minus 5, containing the point -4, 5. Okay, we set it up in the same way. You just have to be way more careful with this because you're going to make mistakes. So our x-intercepts are -2 plus √5 and -2 minus √5. These are our x-intercepts, okay? I just wrote out that plus minus as 2 things because I don't want to get this confused. Okay, so I have some function g of x, doesn't matter what you name it, okay, is equal to some value a that makes it true, multiplying x minus this, so x minus -2 plus √5, multiplying x minus -2 minus √5. Now I can tidy up these negatives and these extra brackets in here before doing any work on this. All right, let's do that. This is equal to a multiplied by x plus 2 minus root 5. So what that negative there did is it flipped all the signs inside there. Notice that all the signs flipped. And then x plus 2 plus root 5. Okay, so there I have it written out a little nicer. Right now, let's take this point here. This is saying that when g of negative 4, this outputs a 5. Okay. That's writing this point in function notation. There's my x, there's my y, there's my output, there's my input, there's my input, there's my output. Okay, so put the output over here. 5 is equal to a times x. Oh, sorry, x is negative 4. Negative 4 plus 2 times minus root 5. And then this is negative 4 plus 2 plus root 5. All right, simplify. This is equal to a times negative 4 plus 2 is negative 2 minus root 5. Negative 2 plus root 5. Okay, and now we can, let me just move the screen so you can see more of my page. All right, so now I'm going to just use FOIL to expand this. So when I use FOIL to expand this, I multiply that times that, and that times that, and then I have this times this, and this times this. So let's see what we get. This is equal to a multiplied by negative 2 times negative 2 is 4. Negative 2 times positive root 5 is plus 2 root 5. Negative root 5 times negative 2 is negative 2 times positive root 5 is negative. See how I caught my sign error there? Yeah. So negative 2 times positive root 5 is negative 2 root 5. Negative 2 times negative root 5 is positive 2 root 5. And then negative root 5 times positive root 5 is negative 5. Why? Root 5 times root 5 is 5. That's the definition of root 5. A number times itself equals 5. That's root 5. So this times this gives me negative 5. These ones are the same. They cancel. So I have 4 minus 5 there is equal to 5. So let's write that out again. 5 is equal to a times 4 minus this plus this. So these are 0 because negative 2 root 5 plus 2 root 5, those root 5s disappear. 4 minus 5 is negative 1. So I have negative 1a. Negative 5 is equal to a. Okay, so then that's my final answer, negative 5. Oh, that's not the final answer. No. I need to put that in up here. Okay, so now I could say, therefore, g of x is equal to negative 5 multiplied by, negative 5 multiplied by, I'll show you here, negative 5 multiplied by x plus 2 minus root 5 multiplied by x plus 2 plus root 5. There. That's my final answer. Check. Done. All right. So that's how you answer those types of questions. Now, if we have an application like question like this, a golf ball is hit and lands 53 meters away. Its path took it just over a 9-meter tall tree, 8 meters away. Find a quadratic function to represent this ball flight. Before you do that, you should visualize it. Okay, everyone has an idea of what a golf ball flight should look like. So it looks like a parabola. It's going to be like this. It reaches its maximum, that comes down here, like that. And we were told the zeros. Let's make this 0, 0, 0. Okay, let's start. I hit the ball at the origin. It's the origin of the ball. Kind of makes sense, right? So there, this is our y-axis here. And it's going to go down there. And this is the point 0, 0. And this is the point 53, 0. We were told that it's on level ground. So this is level with that. All right, its path took it just over a 9 meters tall tree, 8 meters away. So here is 8 meters, and then it's 9 meters tall. So that would be the point 8, 9. All right. So now we have a question very much like the other ones. So now we can find a quadratic function to represent this ball flight. The visualization is really going to help. So is caffeine. So let's carry on. So here we go. I know that we'll call this function g for golf ball, g, and it's a function of x as horizontal distance, is equal to some value a that's going to make it true multiplied by x minus the first root, but that's just 0. X minus 0, I might as well just write x, multiplied by x minus the next root, 53. Okay, now that's great. Sub in this point to solve. So the output was 9, so put that in for the output. 9 is equal to a multiplied by 8 minus 53. Okay, so let's keep going down. 9 is equal to 8 times 8 minus 53. 8 minus 53 gives 44. Okay, 8 times 44. Well, what is that? Well, 8 times 4, so mental math break. It's 480 plus 48, so that's 528. 528. 528a, and that is divisible by 3. So when I do this, divide both sides by 528, I can cancel out at least a factor. I can cancel out a factor 3, but not the whole 9. It's not divisible by 9. It's divisible by 3, though. So what is 528 divided by 3? I want to reduce this fraction, express it in simplest terms. So a is equal to 3 over 528 divided by 3. 528 divided by 3 is, I'm going to go over here. I'm going to push pause. Okay, I use calculators. 176. All right, so we go back here. A is 3 over 176. That's just these numbers, both divided by 3 gives me that. This number is not divisible by 3 because 1 plus 7 plus 6 is not divisible by 3. So that's 14. It's not divisible by 3. So that's my A. Oh, I have a sign error. This was negative. 8 minus 53 is minus 44. So this is negative. And so that means I'm dividing by a negative here and here. That means this is negative. Notice that I made another sign error and I caught it. How did I catch it? Because I have a visualization. Because I know that golf balls go up and then come down again. They don't come down and then go up again. Okay? And that would be a positive A. This is a negative A, so it has to be this way. It has to be negative. And that's how I caught that. Otherwise, I would have made a mistake, okay, without that visualization. I would have had to reshoot the whole video. So now I know the quadratic function, and I can now use that to find the max height. Okay, there's two ways to do the max height. Well, first, write the quadratic function. So g of x, let's write it over here. G of x is equal to a, that's a here, negative 3 over 176. 176. Sometimes, Mr. Jennings, you stumble over the simplest things, copying a number. Negative 3 over 176 multiplied by x minus 53. Okay, so now that's the factored form of this quadratic. And I can find out the maximum value. So that means find the vertex, okay, in two ways. One is I know that the vertex will, because this is symmetrical, that half the distance between here, that would be the vertex. So if I take the average of 0 and 53, that would tell me that the vertex is here at 26.5. That would be its highest point, the middle point of its flight. And then it's going to go down from there. So I would just need to input that into this function and calculate the output. That will give me the vertex. All right. So that's method one. So I'll do that in just a second, but I want to show you what it would look like if I complete the square. Completing the square is going to express this function as a in vertex form, and that would be really useful to find the vertex. So here, I'm going to evaluate this into standard form. G of x is equal to negative 3 over 176 multiplied by x squared minus 53x. All I've done is I've expanded this x into here. And then I would need to multiply those in as well to create the true standard form. But if you remember, the first step of completing the square is going to be to move this out anyway. Okay, so now I can complete the square with this. So now let's say this is equal to negative 3 over 176, and then x squared minus 53x, and I'm going to add something and subtract something. What do I add and subtract? I'm going to take that negative 53, divide it by 2, and square it. And that's going to give me negative 53 over 2 squared, 2,809 over 4. Because that's the number I'm going to add and subtract to this function. Plus 2809 over 4 minus 2809 over 4. Okay? And so I added and subtracted this Jerry Maguire number. I got that by taking half of this and squaring it. And then I don't have any C over here, so this is fine. Now, this here is a perfect square trinomial. All right. So I'm going to rewrite this as negative 3 over 176 multiplied by x minus 53 over 2 squared. Now this is in vertex form. This tells me that the location of the vertex is at 53 over 2. That was the same thing we had with our visualization here. And it will also tell me the location of the y when I remove this. So I have to take this out of the bracket, and when I do, I have to multiply by that. So I have 2809 times negative 3, negative 2809 times negative 3, all over 176 times 4. So let's see, is there anything there that will cancel? Yeah, we'll see. Let's just go ahead and crank her. So I crank that with a calculator. So I have my number here, and I'm going to multiply that by 3 is equal to 8427. That's going to be on the top, plus 8427. And on the bottom, I had 176 times 4 equals 704. Okay, so what was that giving me? That gave me here, when I remove this from the bracket, I have to remember to multiply by this number. So negative 3 times over 176 times 2809 over 4. And that gives me these when I multiply top times top and bottom times bottom. It's a positive because this is a negative times a negative. And that's a positive. That there is the height at the vertex. So remember, the vertex form is like this. It's equal to a g of x is equal to a multiplied by x minus h squared plus k, where hk is the vertex. Notice that the h has to switch signs in there. So this is negative 53 over 2. And connected to our visualization, there's 53 over 2. 53 over 2 is also 26.5. Okay, so that was the location of the vertex. We've used completing the square to find it, and it's 8427 over 704. Now, this is the height of a ball. It's in meters, so we definitely want to give a rounded answer. So let's do that. 8427 divided by 704. Isn't that nice? 11.97. So it's 12. It's 12 high. Okay, 12 meters high. So let's take a look there. So therefore, the highest point is 12 meters. All right, now let's take a look at our visualization. Does that kind of make sense? Like if it goes over this tree and it's 9 meters tall, that it would reach a height of 12 meters and then start coming down again. It traveled 53 meters long. It only went 12 meters high. That's about right. That's about what we would expect that to do. Now, if we were using this method to find the maximum height, you'll see it's a little bit simpler. So I know this is 26.5. That's the average of 53 and 0. And because the parabola is symmetrical, the vertex is going to be right on that axis of symmetry. The axis of symmetry will be located directly between these two. So I take the average, and that's 26.5. And so that I'm going to take my g of x function that's written in factored form still. There's no need to change it. Negative 3 over 176 multiplied by, and then just input your x. So this is actually not g at x. This is g at 26.5. Yeah, that's a g at 26.5 is equal to 26.5 multiplied by 26.5 minus 53. All right, so let's evaluate that. That is equal to negative 3 over 176 multiplied by This is 26.5 times negative 26.5. So we have this as being multiplying by, actually we're multiplying by this number here. This is 26.5 squared right there. Yeah, it's negative that. So it's the same thing. We get the same number. We're going to get the same number. This is going to be the same thing. Okay, so 26.5 times 26.5. Let's just do that on the calculator. 26.5 squared. It's a negative number because I have this one is negative 26.5 minus 53. So it's going to be negative 26.5. So I have that number. It is, where's my plus minus button? There it is. Negative that. And then I'm going to multiply that by negative 3 on the top equals, and divide that by the bottom 176 equals. There. Same thing, 12. Okay. It's 12. It's approximated by the 12. That's how you do these types of questions. So, thank you again for showing up for your learning. I very much appreciate all of the work that you are doing to get ready for Friday, and I hope that you will find me with any questions that you have.